Have you ever wondered how a silly video can suddenly go viral? Or how a tiny investment can, just explode over time? Well, it's not magic. It's actually a super powerful mathematical pattern. It's like a chain reaction that controls how things grow, or even shrink. Today, we're going to unlock the hidden math behind that explosion. We're talking about the geometric sequence. So picture this. You've got the flu. You're laid up in bed, and two of your friends pop over to see how you're doing. You try to be super careful, right? But then you let out one little sneeze. Uh-oh. The very next day, both of those friends are sick. And just like that, the chain reaction has officially begun. And here is where things get really wild: the speed. On day one, it's just two new people. But then, because each of them goes on to infect two more, day two sees 4 new cases. The next day, it's 8. Then 16. You see what's happening? The number of new infections is literally doubling every single day. Okay, so this isn't just a story about being sick. It's a math puzzle. That string of numbers, 2, 4, 8, 16, it's not random at all. It's following a very specific and actually a very predictable rule. So just take a look at this sequence. What's the hidden rule here? How are we getting from 2 to 4? And then from 4 to 8? There's one single operation that connects every single number to the next one. You see it yet? That hidden rule, that secret little engine that's driving this whole explosive growth. It actually has a name. We're about to find the mathematical key that unlocks this entire pattern. It's called the constant ratio, and we usually just label it with the letter R. Finding it is super easy. You just divide any number in the sequence by the one that came right before it. So 4 divided by 2 is 2. 8 divided by 4, also 2. That number, 2, that's our constant ratio. That's the multiplier. And there you have it. Any sequence of numbers where you're just multiplying by the same fixed number over and over and over again, it has a special name, a geometric sequence. Our little flu outbreak is a perfect, a pretty unfortunate example of one. So here's the really crucial part. Once you get the pattern, you can build a formula. And with a formula, you're not just looking back at what happened, you can actually predict the future. This is it. This is the formula for any geometric sequence. And we can map every single piece of it right back to our flu story. So A is our starting number, which was 2. R is our constant ratio, which was also 2. And N is just the day number we're curious about. This formula will tell us T sub N, the number of new infections on that specific day. But hang on. Why is the exponent N minus 1? Well, think about it this way. On day 1, you just have A. You haven't multiplied by anything yet. On day 2, you've multiplied by R 1 time. On day 3, you've multiplied by R twice. See the pattern? The number of times you multiply is always 1 less than the day number. All right, let's put this new tool of ours to the test. We don't have to sit here and write out the whole list. We can use our formula to jump right to the answer. So, how bad is our flu outbreak on day 10? Okay, we just plug in the numbers. The first term A is 2. The ratio R is 2. We want day 10, so N is 10. That gives us 2 times 2 to the power of 9. Now, 2 to the 9th power is 512, and we multiply that by 2, and we get 1,024. Wow. That is over 1,000 people newly infected in a single day. And remember, all of this started from just one sneeze 10 days earlier. That is the incredible power of this kind of growth. Okay, let's have some more fun with this. Let's flex the formula's muscles. What if we know the final number, but we want to know how long it took to get there? So on what day are we going to see exactly 16,384 new infections? So this time, we know our T sub N is 16,384, and we have to solve for N. So we set up the equation, we divide both sides by 2, and then we have to figure out, okay, 2 to what power gives us 8,192? Turns out, that's 2 to the 13th power. So if 13 equals N minus 1, well then N has to be 14. So day 14, just think about that for a second. We can pinpoint the exact day a specific event will happen, all thanks to this one formula. It really is like having a mathematical map that shows you not just where you are, but exactly where you're headed. Now, you might be thinking this pattern is just for, scary viruses. But geometric sequences describe all kinds of change in the world around us. It all just depends on the value of that super important constant ratio, R. When that ratio is bigger than 1, like in our flu story, you get growth. The numbers just get bigger and bigger.
faster and faster. This is the pattern behind things like compound interest or population growth. But what if the ratio is a fraction, a number between 0 and 1? Then every term gets smaller. The sequence is actually shrinking. Think of a bouncing ball that loses a little bit of height with each bounce, or something like radioactive decay.
And here's a really cool one. If the ratio is negative, the terms actually flip-flop between positive and negative. The sequence kind of oscillates as it grows or shrinks. It's a pattern you might see in things like electrical signals or even swinging pendulums.
So, we've seen how all this works, but let's get to the big question. Why is this so important? Why should you actually care about this one little mathematical idea? Well, because this one simple rule, this idea of repeated multiplication, is a fundamental building block of our world. It's used by public health experts to fight disease, by financial planners to help grow your savings, and by tech companies to figure out how ideas spread online. It all comes back to that one really beautiful, simple idea right there on the screen. It's not about making these huge, complicated leaps. It's just about one small, constant multiplication, repeated over and over, that becomes the hidden engine for some of the most dramatic changes we see in the world. So this powerful chain reaction is absolutely everywhere, for better and for worse. It shapes everything from global pandemics to your own savings account. Now that you know the secret, the only question left is, where are you going to see it next?